So looking at lesson 6.6b, more properties of logarithms and how we can use those logarithms to solve equations. So that is what we are going to be looking at. And as we get started, it's important to remember that the relationship between exponential equations and logarithmic equations. So b to the y power equals x. If I know that, then I also know that the logarithm of base b, logarithm base b of x is equal to y. And this relationship is super helpful when trying to solve logarithms. So when we have a logarithmic equation, we're looking for things that we can simplify. And so looking at this first example here, we have a log only on one side, but the left side that contains the logarithm, log base 9 of x, I cannot evaluate that with the calculator or anything else. So the next thing I am going to look at is, will switching the form help me solve the problem? So sometimes when we start these problems, we think we know our best attack plan. We get into it, and then we look and we realize we've actually made the problem more difficult. That's going to happen, and when that happens, you're just going to scratch it and start again, looking for a different way to attack, maybe a different logarithmic property or a different strategy. So there is nothing here. I cannot evaluate that, log base 9 of x. So my second thing I want to look at is, can I change the form? And when we're changing the form, I recommend that you write the generic form above what you're working on, so that when you go to switch the form, right, we're in log form. Now, when I switch to exponential, right, I make sure that everything ends up in the right spot. So log of base b of x is equal to y. So log base 9 of x is equal to the 1.5. I have my relationships set up. So I know when I'm switching the form here that my b value is 9, and then my y value is 1.5, so my exponent becomes 1.5, and then that is equal to x. And then once I get this, right, I see this right here, this 9 to the 1.5 power, I can enter that into the calculator quite simply. So 9 caret 1.5, and I hit my enter, right? I see that x is equal to 27. Right? X is equal to 27. So I can enter this into my calculator, log of 27 divided by log of 9. And if I've done things correctly, I get 1.5. So there we go on example 1. Looking at example 2, my first line of attack would be to look right here, and can I evaluate that? So I'm going to show you a different strategy here in a minute, but my first thing would be, can I simplify log base 4 of 256? So again, I'll use that change of base, log of 256. Make sure to close out that parenthesis, divided by log of 4. Okay, this one gives us a nice solution there of 4 equals 2x minus 8. Right, so then I can solve this. I can add the 8 over. I get 12 is equal to 2x. So then x would be equal to 6, right? I would divide out that 2. So that's how you could attack that one. Another way would be to label things out. Let me just rewrite it over here. Log base 4 of 256 is equal to 2x minus 8. You could try changing the base, right? Change here. Log base b of x equals y. So then I can say b to the y equals x. So when I sub things in, right, I get 4 to the 2x minus 8 power equals 256. When I do this, I have to recognize I need to get my bases the same. So I need a base of 4 to make this work. Requires you to recognize here that 4 to the 4th power is 256, right? So we're really letting the calculator do more of the work when we evaluate that first, then we just solve that, right? We end up with the same thing. We end up with 2x minus 8 equals 4, right? And then our algebra is the same as over here. Add over the 8, divide out the 2, we still end up with x equals 6. This to me is the fastest, simplest way, but this strategy over here works as well. On the right side with the changing the form, and then you have to just try to figure out, can I make 256 into 4 to a certain power? My last example here, I have log base 4 of x equals log base 4 of the quantity negative 6x minus 8. What we can do here, because we have a log on both sides, we cannot just change the form. We also do not have anything that we can evaluate, because over here on the left side, right, I have log base 4 of x. I don't know what x is, so I cannot evaluate it on the calculator. On the right side, same thing, right? I have the minus 6x minus 8 in the parentheses, so I cannot evaluate that. However, right, both sides contain log base 4 of something. And on the left side, it's this x, right here. And on the right side, it's this quantity, negative 6x minus 8. Because they're equal and they're both log base 4, I know that the x has to be equal to the negative 6x minus 8, right, for this whole thing to be a true equation. So now I can work to solve this equation, right? We would add over the 6x. We get 7x equals negative 8. And then I could divide out the 7. I get x equals negative 8 sevenths. So we've done all the algebra correctly. One thing to be cautious of with a negative solution that's going into a logarithm is to check if that is truly a valid solution. And to do that, we can just plug into the calculator, right? Log of negative 8 sevenths divided by the log of 4, right? The change of base. We're trying to evaluate log base 4 of negative 8 sevenths. And our calculator gives us the error of no real answers, right? We have an imaginary solution because we're trying to take the 4th root of, we're trying to figure out a 4th root involving the negative 8 sevenths, and there's no way I can take anything to the 4th power and get negative 8 sevenths. Because of that, negative times negative is positive, times negative again is negative, times negative again is positive, right? We can't get a negative outcome. So our math here, our algebra and our strategies are good, mathematically sound. However, this negative value and it being an even base give us an invalid solution. So something to pay attention to. So that is it for lesson 6.6b. We're taking steps towards incorporating all that we have learned with logarithms and solving equations.